2. Database programming in Java. So when we write the Java code, we potentially run into the problem that there are various different database vendors. Well, 5 are mentioned out there. That's not all there is. I mean, you can see PostgreSQL isn't even mentioned. There are a lot of them. And potentially, each database vendor could say, yeah, sure, I understand SQL. But when you call me, I have decided I have my own very, very good API that you have to relearn every time you get to a new database. To avoid this, Java has the standard Java database connectivity. Nobody ever says that. It's just called JDBC. So JDBC is the standard that Java sets for how do we actually get our SQL into the database and get the response back. Then it's up to the database vendor, because Java is big enough to have requirements of database vendors. It's up to the database vendor to write the correct driver that matches JDBC. So what we then have to do is this. So first of all, we actually need to load that driver. It's important that we find the driver, we download the driver, and then we load the driver in the program. So here I'm going to show you the code that loads the driver, and then in the live demo I'm going to show you how to actually get that driver into your Java program. Once we have a driver, we can start calling the database. We call the database over a connection. So when we establish a connection to the database, or get a connection as it's called in the JDBC, what we'll find is that we have now a line of communication that we can work on. The database is also sort of keeping the connection open at its end. It's using some resources. Also, this is very, very vendor specific. Well, how many resources? But certainly all databases are using some resources once a connection is open. Now we call the database with the statements that we want. I'm going to, in general, just to call it with one statement. That's what you're going to see me do. You can call it with more statements, but typically, once at least the use case is done, you close the connection. Because you don't want the database to have all these resources open. Databases have a limited number of connections that they want to handle, and you can certainly increase that number of connections. No matter how much you increase that, if you don't remember to close the connection, the database is going to stop accepting more connections and your application will be stone dead. Typically, that takes about half an hour. If you have any sort of actually reasonably used application, that takes very long, and then the database is just full. So unless you actually want to restart your database twice an hour, you need to remember to close the connection. You need to be absolutely sure to close the connection, because there is an issue. And the issue is exception. Oh, no, sorry, I'll come back to that. Let me just show you the code to register the driver. Here it is. That's the code to register a PostgreSQL driver. It does require you to set up the driver correctly in your project, but that's the code. Once you've done that, you can do that once in your program, and then you don't have to do it again. It doesn't matter if you do it again. You can do it all over, but there's not much reason to do it all over. You just need to do it once. Here you get the connection. And just to harp on it, you need to close it. So I'll just show you here. This is where you close the connection. And just to harp on it some more, because there's an issue that I was hinting at. Before I get to the issue, let me just show you what's in here, right? So I'm getting the connection from the driver manager, where I register the driver so it knows what to do with it. It returns a connection that I'm going to use in the next section. I give it three things. First, I give it what's called a JDBC URL. JDBC URLs are kind of like URLs, but you can see it seems to have two protocols, so that's kind of weird. So the first part is the actual protocol. It speaks JDBC. Then it has PostgreSQL, which is not really a protocol, but what is the vendor? Then it has what we can recognize as a URL again, // then a host name or an IP address, port number. The port number there is the default PostgreSQL port number, / the name of the database. And if you just install a default Postgres, you get this name for the database. That's the first thing you give it. The two others are optional, but in practice you'll always need them. First of all, you have the username, then you have the password. So you don't put password there all the time. What you put is the actual password, and you can see that I have made a relatively insecure database because it doesn't matter too much, as an example. So, and then you close it when you're done, and there is an issue. So the issue is, when you call a database, things can go wrong. You are sometimes calling it over the network, so you can run into network problems. The database itself could be running low. The server could be running low on hard disk space. That's a common issue. A lot of things can go wrong. Also, things can go wrong because you made a mistake, or made a bug that makes the database choke. So what happens when things go wrong? Well, in Java, when things go wrong, an exception happens. And when an exception happens, you're no longer running your code. You jump out of the code and stop. Until somebody handles the connection. And if nobody handles the connection, either your program stops entirely, or somebody, something somewhere just prints your connection and keeps going anyway. Your exception, sorry. But your connection is not closed because it jumps out of your code. In order to make sure that it is closed, we used to need try finally. So I want to show you, because you're still going to see code that uses it. But that's typically some pretty old code. You might have seen that when you worked with files. Right, you get a connection. If you get an exception in the first line where you get a connection, this on the right hand is the driver manager.getConnection stuff. If that fails, well, the connection was never open and you don't have to think about that. But once you're past that line, your connection is open and you have to throw it, have to close it. So you go into a try. And in that try, you code a lot, and all that code, a lot of the code could throw an SQL exception. If you use a connection, you can throw an SQL exception, always. That's why you put the connection.close in the finally, because the thing about finally is that it guarantees that that line is run, no matter if there is an exception or not. You can't use a catch, because catch only runs if there is an exception. And typically, hopefully, you will not have an exception. So you use the finally. So this was the code to write for, well, over a decade, I suppose. And then something new happened because people got really, really tired of writing code like this. But the problem still exists, so you do have to do something. So this is the shorter try, where instead of before the try, you get the connection in the try in braces. Then you don't have to write connection.close because it auto-closes this connection. This is the code you're going to see me use. It is much shorter. There are fewer errors you can make with it, and it is especially good if you're opening several things that needs to happen. But in general, as you can see, this is just shorter code that's easier to write. So this is what you're going to see me use. Okay, let's see what we do with the connection. So what we have here is a prepared statement. So the rhythm, there are alternatives, but they're not good. The rhythm of this is prepare a statement, then execute the statement. And I mean, for the very simple cases, that's just a 2-line and you don't have to think too much about that. For more involved cases, and that's what we're going to get to, there is more to preparing a statement than just calling prepare statement. So let me first go into, we execute the statement, and there are 2 different ways of doing it. If it's an insert, update, or delete statement, you execute update. And I think you already by now have figured out that insert, update, and delete are quite a bit different from select in many ways. Right? If you select, you're going to see a result. You're going to see some sort of table or table-like structure, because it's not a table in the database. And when you insert, updating, and deleting, you're seeing nothing. If you're seeing anything, because you are, if you do it in pgadmin, it will tell you how many rows were affected by this. How many rows did you insert or delete, or how many rows were changed because of the update. You're going to see that. It's just a number, and the other is a rather more complex structure, which is the reason why we have 2 different methods to call, because execute update returns an int, the number of rows affected, as I just said. Execute query returns this complex result that we call a result set. And in a few slides, you'll see how to work with a result set. But in a result set is a set of rows that you can work with one at a time and then move on to the next. And you will see in the code, I think, what I mean by that. So, first of all, let's take the simple first and simply see an execute update. So I insert Franz Kafka into the table. Fine. Right. As I said, you prepare a statement, then you execute the statement. Done. I have remembered the quotes around Franz Kafka, and I remember that I'm writing SQL, so they are single quotes. But this is a piece of Java code that can do one thing, and that is to put the author Franz Kafka into a table. What if it's not Franz Kafka? What if it's, well, Douglas Adams, as I just said? What if it's something else? What if it's something that the user puts in there? Well, typically, if there's something the user puts in there, it ends up in some sort of variable. So what I want to show you on the next slide is how to have a value in a variable. How do we actually get that to the database? And there are good ways of doing it, there are bad ways of doing it. I'm going to show you the good ways. Then, in the 4th video, I'm going to tell you why the bad ways are bad. So, author named Franz Kafka. I haven't done much. I mean, it still just inserts Franz Kafka, but I am using a variable, so you can, I think, imagine how any line below this could be used to actually insert anything that the user put in there. So what have I changed? Well, no, the values. That's no longer the string Franz Kafka. You note that I also removed the quotes, because that's a common mistake to make. Just a question mark. So a value to be mentioned later. How much later? Well, next line. So in the next line, I'm putting in which value was it. So set string on the statement, 1, author name. So author name is the value. That's Franz Kafka. 1 means the first question mark. Because this is a very, very simple table. It has a name and it has an ID. And the ID is auto-filled, so I only fill out the name. So I only have 1 question mark. But book has 4. So that would be 4 question marks. So that would be 4 set string, set int, 2 set string and 2 set ints, I guess, with the values 1, 2, 3, 4. You will see that in the live code, but just keep in mind, the reason there's only 1 line and there's a 1 there is because there's only 1 question mark. That is not necessarily typical. So this is how we do that. This is the general way of doing this in a way that's good, safe, and efficient. More about the bad ways much later. So here we have another. This is how we select. So I just kept the symbol select name from author. We get all the names and I want to print them out. So again, we have first we prepare a statement, then we execute the statement. So we prepare the statement, select name from author. I just want all the names. There's no need for user input here, so there's no question mark. We execute with the query. As I said, it returns a result set. And now we need to work with it. So it's one row at a time, and then we move to the next, as long as there are still things to move. So if we try to remove to the next and there are no more, it will return false. Otherwise, it will return true. It's made for this. It's simply made to say while r is .next. You might have wanted it to be some sort of for loop. I think I want it to be some sort of for loop, but there's not a lot we can do with that. It's simply made to be a while r is .next, and we just have to accept it. So this is the way to write. You go through every row each at a time, and in this particular case, I just write out the name. So you can see, just as I could set string on a statement, I can get string from a result set. And I give it, the name there is the name from SQL, from the select name. I just use that as a parameter to the get string. And then I can print all the names. And that's it for working with a result set.